Hello, everyone. Thanks for being here. Today, I'm going to take you through something that's actually all around us, whether we know it or not. Naphtha Cracking. I am Aja Bonfo, and I'm presenting on behalf of Group 1. Okay, so let's get started, shall we? So, first things first, what do we actually get from naphtha cracking? The main goal is to produce light olefins, mainly ethylene and propylene. These tiny molecules are huge in impact. They are the building blocks for plastics like polyethylene and polypropylene, synthetic rubber, and tons of everyday chemicals. In short, without this process, most of the modern petrochemical industry simply wouldn't exist. Okay, so what's cracking exactly? It's pretty much what it sounds like. We take big hydrocarbon molecules from naphtha and crack them apart into smaller, more useful pieces. In this industry, we mainly use two methods: thermal cracking, which relies purely on heat, and steam cracking, which adds steam to the mix to make the breakdown more efficient. Steam cracking is the main method for naphtha. The goal here is simple: take big, heavy hydrocarbons and break them down into valuable small olefins. To do this, we push the feedstock to super high temperatures, around 800 to 850 degrees Celsius, and inject steam to help the reaction along. It's hot, fast, and very precise. Let's go ahead and break this down step by step. First, we heat the naphtha in the furnace to reach those extreme temperatures. Then comes the actual cracking, where the large molecules split apart. Next, we quench the gas quickly. That means we cool it rapidly in a quench tower to stop unwanted side reactions. Finally, we move on to separation, where the cracked gases are fractionated into products like ethylene and propylene, ready for downstream use. But of course, a cracking plant isn't just a reactor. You've got the control room, which is the brain of the operation, monitoring, adjusting, and keeping things safe. The admin block is where the staff and the managers handle day to day tasks. The laboratory tests product quality and checks that everything meets strict specs. There's also the security gate for site access and storage tanks to hold both raw naphtha and finished products. None of this works without constant measurement. We use pressure, flow, and level sensors to keep tabs on tanks and towers. Gas analyzers check that ethylene purity stays on point. Even something simple like a barcode system in the warehouse makes sure that inventory is tracked accurately. Behind the scenes, there's a lot of hardware making sure all of this runs smoothly. Operator screens and panels display live data to the people in the control room. Control valves and actuators automatically adjust flow rates or open and close as needed. Alarms and sirens warn operators if something goes off spec. And if things go really wrong, the emergency shutdown system steps in to keep the plant and everyone in it safe. Hardware is only half of the story though. We rely heavily on software too. Simulation software lets engineers test how to run the cracking units more efficiently without risking the real thing. LMMS, or Light Material Management System, keeps track of how cracked products are purified, stored, and routed. CMMS, or Computerized Maintenance Management System, handles scheduled meetings so we don't wait for something to break before we fix it. And of course, strong cybersecurity protects all this from digital threats. To tie everything together, you need solid connectivity. A wired LAN connects devices inside the plant, fast and stable. Field bus or CAN networks link up sensors and field devices to the main control system. The office LAN connects admin computers, servers, and internal communications. So, how do we keep this network reliable? A star topology is usually the backbone. All devices link back to a central hub or switch. It's simple, easy to manage, and if one device drops out, the others stay online. We can strengthen this with ring or mesh topologies. Extra connections mean if a cable fails, there's another route for data. Segmentation splits the network into logical chunks, process control, safety, admin, so traffic doesn't get congested and each area stays secure and responsive. That wraps it up. Thank you all for listening. I hope this gives you a clearer picture of how naphtha cracking works and how we keep the whole process connected, safe, and efficient. I'm happy to take any questions you have. Just leave them down in the comment section below. Thank you once again. Bye.